Let's start from the beginning. Before the light bulb, people used candles and oil lamps, which were messy, dangerous, and didn't provide much light. Scientists and inventors knew there had to be a better way. The light bulb story begins in the early 1800s. Humphrey Davy, an English chemist, demonstrated electric light in 1802. He experimented with electricity and invented an electric battery. When he connected wires to his battery and a piece of carbon, the carbon glowed, producing light. But it didn't last long and was too bright to be practical. His invention was known as the electric arc lamp. For the next 7 decades, other innovators developed their own versions of the light bulb, but none were suitable for mass production. Notably, in 1840, British scientist Warren de la Rue created a breakthrough design featuring a coiled platinum filament within a vacuum-sealed tube. He cleverly leveraged platinum's high melting point to withstand extreme temperatures and minimize reactions with gas molecules by evacuating the chamber. Although his design was efficient, the hefty cost of platinum made it impractical for large-scale commercial use. In 1850, Joseph Swan, a British physicist, also made significant contributions to the development of the incandescent light bulb. He experimented with different materials and found that carbonized paper filaments worked well. In 1878, he demonstrated a working light bulb, but it still wasn't perfect. The light didn't last very long and the bulbs were expensive to make, but it was Thomas Edison who, in 1879, developed the first practical and durable incandescent light bulb using a carbon filament. Thomas Edison was a famous inventor, known for his work on the telegraph and phonograph. He set up a laboratory in Menlo Park, New Jersey, where he and his team could experiment and invent new things. Edison used a high-resistant carbonized bamboo filament and a vacuum-sealed glass bulb to build the light bulb. This invention changed how people lit their homes and businesses, making indoor lighting much easier and more efficient. It lasted longer and was cheaper than the previous versions. Light bulbs have undergone significant evolution over the decades since Thomas Edison's invention. Over time, carbon filaments were replaced with tungsten filaments, which lasted longer and emitted a brighter light. In the 1930s, fluorescent lighting was introduced. These bulbs use an electric current to excite mercury vapor, which produces ultraviolet light. This light then causes a phosphor coating inside the bulb to glow. Fluorescent bulbs were more energy efficient than incandescent bulbs and had a longer lifespan. In the 1980s and 1990s, compact fluorescent lamps, or CFLs, became popular as a more compact version of the traditional fluorescent tube. They were designed to fit into standard light fixtures. CFLs offered significant energy saving compared to incandescent bulbs and had a longer operational life. The late 20th and early 21st centuries brought a revolution with light-emitting diodes, or LEDs, which use semiconductor chips to produce light. LEDs are highly energy efficient, longer lasting, and increasingly cost-effective and affordable. LEDs are extremely energy efficient, converting most of their electricity into light rather than heat. LEDs were initially used as indicator lights in electronic devices, but advancements in technology allowed them to be used for general lighting by the early 2000s. They have a much longer lifespan compared to incandescent and fluorescent bulbs. LEDs come in various colors and can be easily dimmed, making them versatile for different lighting needs. The latest advancement in lighting technology is the integration of smart features. Smart bulbs can be controlled via smartphones or voice assistants, allowing users to adjust brightness, color, and scheduling remotely. Smart lighting enhances convenience and energy efficiency and can even integrate with other smart home systems for improved automation and security. This shift in technology has led to a decline in the use of incandescent and fluorescent bulbs. Now, let's look at the process involved in making light bulbs. Manufacturing light bulbs involves several precise steps to ensure each bulb meets accurate quality standards. The first step in making light bulbs is gathering all the necessary materials. This includes the glass bulb, filament, semiconductor chips, inert gases, and other components like bases, connectors, and other parts needed to complete the bulb. In this step, factories source high-quality materials to ensure that the bulbs they produce are durable and efficient. After gathering the materials, the second step is the glass bulb production. In the process of making glass bulbs, molten glass is blown into molds to form the bulb shape. Different molds create different shapes and sizes of bulbs. Some bulbs are round while others might be longer or shaped differently for specific uses. After shaping, the glass is cooled slowly to prevent it from cracking. This step ensures that the bulbs are the correct shape and size for the type of light bulb being made. Most of the time, automated machines ensure consistent size and thickness. The third step is filament manufacturing. The filament is the part of the bulb that gets hot and produces light. In the creation of filament, thin wires, usually made of tungsten, are drawn through dies to achieve the desired thickness. It's then coiled or formed into a zigzag shape to increase surface area and improve efficiency. Afterward, it is carefully placed inside the glass bulb and attached to support wires and a metal base for electrical connection. This assembly is fused to a glass bulb. The filament is the other part of the bulb that lights up, so it must be installed carefully to ensure it works correctly. This is followed by the inert gas filling. In incandescent bulbs, the bulb is filled with an inert gas like argon or nitrogen to prevent oxidation of the tungsten filament, while different gases and materials such as semiconductor chips are used for fluorescent bulbs. These chips produce light when electricity passes through them. The fifth step is the sealing of the bulb. The bulb needs to be sealed so as to keep the gas inside the bulb. The open end of the glass bulb is melted and sealed shut with a high temperature flame to create a vacuum or maintain specific gas pressure, which is important for the bulb's longevity and performance. Then, a metal base, usually aluminum or brass, is attached to the bulb's bottom, containing electrical contacts for connection to the power source. Moving on, we get to the testing and quality control. Before bulbs are sold, they need to be tested to ensure that they are working correctly. Each bulb is turned on to make sure it lights up properly, and they are then tested to see how long they last if they can handle being turned on and off repeatedly. Any bulbs that don't meet the factory standards are discarded or recycled. Testing helps ensure that customers get high-quality bulbs that will last a long time. The modern light bulb, which is LED bulb production, is quite different, and it involves assembling LED chips on a ceramic or aluminum base. This part is then attached to a heat-dissipating component and then connected to a driver-printed circuit board. The entire assembly is placed in an enclosure and connected to a base that contains AC/DC contacts or connections for easy installation. The LEDs are automatically covered by an automated system, completing the production process before testing. From the first incandescent bulb created by Edison to the advanced LED bulbs we use today, light bulbs have come a long way. They continue to light up our world thanks to the innovation and hard work that goes into making them. Thank you so much for watching. If you enjoyed learning about the invention of the light bulb, be sure to share your opinions in the comment section below, like the video, and subscribe to our channel for more fascinating stories from history. And remember, every great idea starts with a spark.